So what's the big deal if NOAA proposes carbon dioxide removal research? Well, it's interesting, at least for me, because NOAA, the National Oceanic and Atmospheric Administration in the US, is typically doing lots of weather service, climate prediction models, also does a lot of applications for hydrology, fisheries, health, agriculture, and so on. And now it's proposed this strategy for NOAA carbon dioxide removal research. It's interesting because they also use NOAA's climate interventions portfolio as a strategy document here. So NOAA CDR science strategy as an element of NOAA's climate interventions portfolio. So it's interesting strategy and proposition because a climate services entity can take on CDR carbon dioxide removal as a part of its portfolio. Then you get a home for CDR. In general, who does it in any country? India would have to think of this as well. So I'm mostly doing this as something that can work for everybody. So what is this document about? This document was developed by the National Oceanic and Atmospheric Administration Carbon Dioxide Removal Task Team, CDR Task Team, across NOAA interdisciplinary team with relevant expertise in climate and carbon, coastal and open ocean science, aquaculture development, and ocean conservation. So they have lots of assets on the ground, in the oceans, in space, and so on, that they can bring to bear, including ships, aircrafts, and so on, to do CDR research. In November 2020, the CDR task team was charged by the Senior Research Council of the NOAA Office of Ocean and Atmospheric Research, OAR, with devising a draft portfolio of CDR strategic research needs in support of a broader climate recovery strategy pursuant to Section 214 and 216 of White House's Executive Order, which was endorsed by the NOAA Science Council in January 2022. This document also contains information relevant to White House memo, multi-agency research and development priorities for the FY 2023 budget. So the way that things go is that 2023 budget gets set in 2022, I guess. So the document is obviously not published this year, but it's from previous years. But all the points are more about the strategy, and obviously then implementing it requires a lot more work. So I wanted to go through it. We've already covered the basics of CDR, various methods. That's not the point here. The NOAA task force does a good job of saying what are the synergistic activities that NOAA already has for this, what additional resources they will need, and so on. So let's read the executive summary, and then we'll flip through some figures from the rest of the report, which is, I don't know, about 50, 60 pages. How to use this document. This document is intended to serve as a reference for exploration of carbon removal research at NOAA. The report was drafted by authors from across NOAA to provide strategic direction to relevant labs and programs in multiple line offices. Line offices are what fit into various NOAA branches administratively, like Office of Ocean Atmosphere Research then has various things, right? The goal has been to assemble as much information as possible in order to facilitate conversations about carbon dioxide removal, or CDR, at a high level within the agency. This document will be used to develop an implementation plan for CDR research at NOAA in the event that Congress instructs the agency to engage in the emerging research front. So they're not proposing to implement it, but provide the research basis, pros, cons, implementation strategies, etc. This report does not endorse any specific CDR activity, technique, or application. Rather, it's similar to recent reports released by the National Academies of Science, Engineering, and Mathematics, the Department of Energy and the Energy Futures initiatives, which note that more research is necessary. This report also does not compare or contrast nature-based and engineering CDR techniques focused on emissions reductions such as carbon capture, utilization, and storage. So we'll touch on nature-based CDR, which we have already covered a little bit elsewhere, but we'll look at this in the NOAA strategy context. The goal is to explore NOAA's role in assessing negative emission strategies, which are techniques that remove carbon directly from the atmosphere and marine systems. We already know that. So the report has 4 parts: introductory section, review of potential CDR techniques and where they are currently, synopsis of NOAA's key assets, which is very important because they have a leg up on doing this, and a vision of CDR research at NOAA. Okay, so I don't want to read, I already have cut the text down to very little, but just in terms of executive summary, these are the summary of key findings of this report. Scientific motivation, parts 1 and 2, we already know why this CDR is needed. Basically, limiting warming to levels that avoid extreme risk requires immediate and substantial reductions of greenhouse gas emissions, as well as the removal of carbon dioxide from the atmosphere that's already accumulated. While emissions reductions approaches are the primary component for addressing this challenge, negative emission strategies will be essential for keeping global temperatures at or below target levels. Negative emissions essentially means we will take out more CO2 than we put in. There will be irreducible emissions even if we decarbonize completely from natural sources, let's say. So taking those out we call negative emissions technologies, and there are some details. So we will see each of these in the report. So the report includes summary of several techniques, each of which is compared in a table that we'll look at, which shows the current understanding of the relative strengths and weaknesses of each technique, as well as NOAA's potential contributions. So they are pitching for NOAA to lead this research in case Congress decides some agency has to lead it. Additional information visualizing the data in Table 1 can be found in figures that we will look at. So there are several comparisons done. NOAA's role itself, NOAA's global to coastal observing networks gives it an advantage, and it has data simulation capabilities to do optimal deployment, let's say, of CDR techniques on land, atmosphere, and ocean, including nature-based and engineering approaches. NOAA's system and regional ocean modeling capabilities could be used to assess and inform the scale up of land and ocean-based methodologies, so that you can also track the impacts of CDR, right? It's good that we want to take out CO2, but we have had impacts by increasing CO2 and greenhouse gases. What happens if we start drawing it down? What will be the impact? What will be the beneficial and deleterious detrimental effects, and where they will occur, and so on. NOAA's ecosystem research is well suited to study the potential ecosystem impacts of atmospheric and marine CDR deployments. NOAA's decision support and ocean planning infrastructure, including the agency's management role and stakeholder relationships, could help create essential data and data product infrastructures to resolve use, siting, management, and conservation challenges. Right? Obviously, they are pitching hard. What is the vision? A vision of NOAA CDR research in the future. So part 4 of the report goes into that. We'll touch on it a little bit. We offer a vision of how NOAA may engage CDR research in the future. Estimates indicate that between 400 and 1,000 gigaton carbon must be, so that's 1,000 gigatons is a lot, must be removed from the atmosphere and sequestered safely by 2100. So if you look at the cumulative CO2, we know how much more we can emit just approximately in terms of trying to stay below 2 degrees C or 1.5 degrees C. So we need to remove this order of CO2 or carbon from the atmosphere. So atmosphere is what affects global warming and extremes and everything else, but ocean also is storing a lot of CO2 that we're trying to put in more, but we have to worry about acidification and all those good things, right? So given the necessary pace of infrastructure development to meet these goals, the construction, engineering and equipment manufacturing sectors associated with building CDR facilities could see at least 300,000 new jobs by 2050. This is necessary because the US, especially the current president that just got elected and just came into office, always looks at these things. He may be a skeptic or denier of climate change, but if there is job creation associated with these solutions, then the game may change for him in his head. Such an effort would gradually build to field studies as each technique matures and then broaden to application of sustainable, effective methods of carbon removal. Throughout this three-stage process, it will be imperative to act with the highest standards of transparency and scientific integrity, which is all important. So it's obvious the document focuses on NOAA's potential role in CDR and how its mission and capabilities, including through grants to external entities, map to specific CDR needs. So the task force is basically arguing that CDR is going to be inevitable, and NOAA is the best agency maybe in the US to lead this, and whatever NOAA does is going to obviously benefit everybody else also, rest of the world, if they share the research and so on. Typically they do. And in terms of just what is needed for CDR, additionality is important. In other words, whatever we do has to be shown to be sequestering carbon that wouldn't have happened naturally, right? So you need a counterfactual baseline to show that we are putting down or sequestering more CO2 or carbon than would be going in by itself. Robust measurements of gross removals, quantification and calculations that account for the emissions in the production and supply chain of the removal projects themselves. So in a life cycle analysis sense, you have to be really removing CO2. For example, if you are deploying direct air capture machines and they're using a lot of energy, and that energy is actually emitting CO2, and you only count the CO2 being removed by the machines, then in a life cycle sense, that's not a good story, right? Durability, so it has to be stored at low risk and has to be put away for a long time, and you have to make sure that leakage doesn't happen, right, with unintended consequences also. Just briefly, it looks at technological readiness of these approaches, estimated costs in terms of dollars per ton of CO2 removal, which is also very important, scale potential, so that how many gigatons of CO2 can you remove per year, and duration of storage, and what NOAA potential impact will be, and what NOAA catalysts are. So let's not read all the things, but alkalinity enhancement, we'll come back to that. Coastal blue carbon, we have discussed each of these already, but we'll look at this these here in terms of what NOAA is proposing as its role in CDR research. It's CDR research, not implementation, remember. Ecosystem recovery, we'll see what that means. Microalgal cultivation, we've talked about this in terms of drawing down more CO2 into the oceans. Direct air capture, of course, which is the most common method that's being discussed now. Climeworks and others are already selling big units that do direct air capture. They're not impressively large in the potential, so the duration storage can be high in terms of geologic time scales can be 1,000 years, and scale of potential is low to high depending on which method is being used and what the technological readiness level is, and so on and so forth. It's high, but cost can be low to high, so as low as $40 per ton of CO2 removal per year, but also can be as high as 1,000. So there is how this will work out is not clear, because if it is allowed as an offset, maybe some companies will pay $1,000 per ton to remove CO2 to offset their emissions. So we have to see how this plays out. Direct ocean removal, of course, another thing we'll discuss. So NOAA has various ways in which it sees as being ready to take this on. For example, here for macroalgal cultivation, NOAA is the national clearinghouse for monitoring spatial planning for macroalgal aquaculture, which is a industry that obviously makes money and is part of the food security as well. Ecosystem recovery, NOAA is a national leader in coastal blue carbon monitoring, conservation and restoration. So obviously they are pitching hard, but it's also true what they are saying. Ocean fertilization, bioenergy carbon capture and storage, BCCS or BECS as it's called. Sometimes afforestation and reforestation, artificial upwelling and downwelling, and soil carbon. So you can see some of these are considered nature-based solution or natural climate solutions as well, and again they all have various levels of potential, cost, technology readiness, and NOAA's potential and NOAA's activities that can accelerate these particular approaches. This is NOAA's potential, again looking at the various approaches: direct air capture, soil carbon, afforestation, etc., as we already saw. And again, this is a table that's showing duration, effectiveness, cost, and technological readiness as a bar chart of the table that we looked at. Okay. What is effectiveness? That's gigaton of CO2 removal per year. So low cost and low effectiveness here. So how they all fit in, and you are going here in higher potential for removal, but here is the cost. So some things have high cost and low effectiveness, and you want things that have high cost maybe but high effectiveness, but ideally you want low cost and high effectiveness. So you have alkalinity enhancement and soil carbon up here. Soil carbon has a virtuous cycle where increasing soil carbon also affects soil health, crop yields, soil moisture persistence, drought resilience, maybe groundwater recharge, and so on and so forth. Direct ocean capture here, high cost, high effectiveness, but here you have a lot of things that are in the low cost, low effectiveness, or high cost and low effectiveness. So this is kind of the estimates that you have to be careful about, because many of these are current state of affairs as people keep doing research and lots of private entities are getting into this business. You may jump from here to here, or from here to here, and so on and so forth. Okay, a lot of money there to be made, so everybody is trying to get into this business. So I'm skipping many of the introductory plots on carbon cycle and so on, but this is about the processes that influence the climate system. We already looked at this in the Earth system courses and so on, but this is essentially the Earth system science piping diagram. So you have forcing, climate variability and change is what we are looking at. We have atmospheric chemistry that we have to worry about, and all the Earth system processes and feedbacks within the system. And like ocean atmosphere, land atmosphere, ocean atmosphere interactions, contributions and responses and feedbacks, human activities like agriculture, urbanization, transportation, impacts like glacier melts, and of course industrial activities that we are trying to do, on top of the remedies we are looking for in terms of removing the carbon dioxide. So we want to use these to see where we can use natural processes to sequester additional carbon for reasonably long times, and what the engineering solutions are. So always a combination, right? So we'll see how these are all part of the story. Okay, so if I'm long enough on this one, then we can come back and do it as the next podcast. Yeah, so this is almost 19 minutes. This will be at least 2-3 podcasts, so no need to cram everything into one podcast, but you get the idea. NOAA, National Oceanic and Atmospheric Administration, is proposing a strategy for doing CDR research, and is arguing hard that they have everything in place to take this on and hit the ground running, as they say, and they have lots of assets. These observation systems, ships, aircraft, satellites they have, these take time to build. If they are already in place and can already be used for doing CDR research, then obviously they have a huge advantage. But there may be other agencies like the Department of Energy who may be proposing similar things, or they will be working together. But each agency has to fight for its money as well. NASA may be in the business, and so on and so forth. So we'll come back and look at more specific things in terms of the approaches and what NOAA sees as its role going forward. Okay, see you in the next part of this report summary.